Welcome dear students. I am Dr. D. Tabhita from Department of Mathematics from Andhra Loyola College. Today I want to discuss on the topic differential equations. So, what are the course outcomes of this differential equations? Students will be able to identify differential equations which are exact. They will be able to recognize the conditions that make an equation exact, and also students, you will be able to be proficient in solving exact differential equation through the method of integrating factors. Students will be able to solve real world problems in various scientific and engineering domains. So, coming to how is a differential equation formed? We will be hearing about differential equations, but how is it formed? A differential equation is formed involving the derivatives of the unknown function describing fully and accurately the physical process or a geometric law. For example, if you take the family of parabolas, parabolas are denoted by y square is equal to 4ax. So, here a is called the parameter. We will be eliminating the parameter by differentiating. So, thus a differential equation is formed. In content, how is the real definition of an differential equation? An equation involving differentials or one dependent variable and its derivatives with respect to one or more independent variables is called a differential equation. What is meant by a dependent variable and independent variable? What is meant by a variable? X, y, z and so on are called variables. dy by dx, here y is called the dependent variable. This y variable will be dependent on x, that means x is called independent variable. So, a differential equation, it has differentials or one dependent variable, that means the dy or dx or dz, it is called dependent variable. With respect to, we may have two or more or one or more, we can have independent variables. Then what is meant by an ordinary differential equation? A differential equation is said to be ordinary if the derivatives in the equation have reference to a single independent variable. Differential equation may have two or more, one or more independent variables, whereas ordinary differential equation should have only one independent variable. So, what is meant by an order of a differential equation? Order. A differential equation is said to be of order n if the nth derivative is the highest derivative in that equation. We will be taking a differential equation. For that, we will be having orders, that means d square y by dx square, dy by dx. An equation will be of the form d square y by dx square minus 4 into dy by dx plus 7y is equal to e power x. This is a differential equation, but what is the order of the differential equation? That means the highest order, that means square, that is called the order. D square, d cube, cube means 3 is called the order. That here we have taken the example here, in our example 2 is the order of the differential equation. And coming to degree of a differential equation, what is the degree? The highest degree of a differential equation is defined as degree. That means we have taken the order of an equation. That differential equations, the highest power of the order is called the degree of a differential equation. Now, coming to differential equations of first order and first degree. So, differential equations of first order and first degree, we have numerous types of differential equations. In that, we will be discussing today about exact differential equations. So, exact differential equation is of the form m dx plus n dy is equal to 0. In a nutshell, the definition of an exact differential equation is the equation m dx plus n dy is equal to 0 is said to be an exact differential equation if there exists a function f of x comma y, that means we will be having x variables, y variables, and having continuous partial derivatives in R, that means in the set of real numbers, such that it is defined as d of f of x comma y is equal to m of x comma y into dx plus n of x comma y into dy. In general, we will be writing an exact differential equation of the form m dx plus n dy is equal to 0. What is the necessary and sufficient condition for an exact differential equation? The necessary and sufficient condition for an exact differential equation m dx plus n dy is equal to 0 is dou my by dou y is equal to dou n by dou x in the set of what the set we take, that set is called, here we are taking the set real numbers, that means dou m by dou y is equal to dou n by dou x. When this condition is satisfied, that is called an exact differential equation. So, how to solve an exact differential equation? So, we will be taking step number 1. Let us take the differential equation. We should first of all, we should compare the differential equation whether it is of the form m dx plus n dy is equal to 0 or not. So, we will be comparing the given equation and we will be identify m and n. So, then we will be finding out dou m by dou y and then dou n by dou x. So, the given equation will be exact if dou m by dou y is equal to dou n by dou x. Then integrate m partially with respect to x and treating y as constant. Then we will be denoting as integral over x m dx. And then we will be integrating only those terms of n, that means the terms which do not contain x in n. We will be having n, but we will be integrating those terms which do not have x, and we will be integrating with respect to y. And the next step is we will be equating the results of which we have in step 3 and 4. That means finally we will be getting the general solution as integral m dx over x plus integral n terms not containing x into dy is equal to c. That is the working rule for solving an exact differential equation. For example, if we take a problem here, e power y plus 1 into cos x dx plus e power y into sin y dy is equal to 0. That equation is of the form m dx plus n dy is equal to 0. So, we have compared the given equation. Now, identify m and n. Here in this example, m is nothing but e power y plus 1 into cos x and n is equal to e power y into sin x. So, we will be differentiating. So, differentiating partially dou m by dou y. We are differentiating m with respect to y. M is here e power y plus 1 into cos x. So, when we differentiate, we will be differentiating the terms of y. The terms of y is here e power y. In d by dx of e power y is e power y itself. That means dou m by dou y is equal to e power y into cos x. Now coming to x. N. What is n here? E power y into sin y. So dou n by dou x. So here x term is nothing but sin x. So d by dx of sin x is cos x. So e power y into cos x. So both the terms are equal here. Dou m by dou y is equal to e power y cos x and dou n by dou x is equal to e power y cos x. So both are equal. So the given given equation, the given differential equation is an exact differential equation. So when it is an exact differential equation, we'll be integrating m. What is m here? E power y plus 1 into cos x dx. Will be integrating with respect to x. So integrating with respect to x, we'll be getting here e power y plus 1 as constant, and integral cos x dx is nothing but sin x. Now coming to n, integral n, terms not containing x. So terms not containing x in n is nothing but no term is there. So that is nothing but integral 0 dy, that is equal to 0. So the general solution will be e power y plus 1 into sin x plus 0, that is equal to c. So finally the solution is e power y plus 1 into sin x is equal to c. That is an example for an exact differential equation. We may get a doubt. If it is not exact, that means if the equation is of the form m dx plus n dy is equal to 0, and if it is not, if dou m by dou y is not equal to dou n by dou x, what should we do? So we'll be looking at that. So we should reduce the given equation to exact form. How will we reduce the equation to exact form? By using integrating factors. So what is meant by an integrating factor? Now look at the definition of an integrating factor. So let m of x comma y into dx plus n of x comma y into dy is equal to 0 be not an exact differential equation. It can be made exact by multiplying with a suitable function. So that suitable function is called an integrating factor of the exact equation m dx plus n dy is equal to 0. So we have different methods to solve the different integrating factors to make an equation exact. So how do you find out? First of all, we'll be using one method here. So first type 1, m of x comma y into dx plus n of x comma y into dy, that means m dx plus n dy, if it is an homogeneous differential equation. What is meant by again a homogeneous differential equation? The orders should be same. That means if m power and n power are equal, then it is called an homogeneous differential equation. So m dx plus n dy is equal to 0. If the given equation is an homogeneous equation, then we'll be using an integrating factor. What is that integrating factor? 1 by mx plus ny. But there is a condition that mx plus ny should be not equal to 0. But then only we'll be using the integrating factor 1 by mx plus ny. So this 1 by mx plus ny is an integrating factor of m dx plus n dy is equal to 0. So how do you solve and how do you use an integrating factor? Coming to working rule. So let the given equation be of the form m dx plus n dy is equal to 0. We'll be identifying m, n, and we'll be finding out dou m by dou y and also dou n by dou x. But here dou m by dou y is not equal to dou n by dou x. Then we should use an integrating factor. Let us verify or observe whether m and n are homogeneous functions of same order. Homogeneous function is itself, in other words, it should be of same order. So if it is of same order, we'll be finding out mx plus ny. If mx plus ny is not equal to 0, then we'll be taking 1 by mx plus ny as an integrating factor. So we'll be finding out 1 by mx plus ny. Now multiply this integrating factor to our original equation m dx plus n dy is equal to 0. Then we'll be getting a new equation m1 dx plus n1 dy is equal to 0. m1 dx plus n1 dy is equal to 0 is again an equation. So we'll be identifying m1 and n1, and again we will be finding out dou m1 by dou y, dou n1 by dou x. So, if they are both equal, then they will be both equal. When we multiply with an integrating factor, they will be both equal. That means dou m1 by dou y will be equal to dou n1 by dou x. Again we will be finding out integral m1 dx, treating y as constant, and we will be taking integral n dy, treating y terms as constant, and we'll be finding out the general solution. Similarly, we have number of integrating factors. That means we have 4 types of integrating factors. First of all, we have seen an homogeneous differential equation. That means the integrating factor for that is 1 by mx plus ny, and the other integrating factors are 1 by mx minus ny and 1 by n into dou m by dou y minus dou n by dou x, and 1 by m into dou n by dou x minus dou m by dou y. By using these integrating factors, we can make an differential equation to be exact. Thank you.